Of EMF is 1.5 volts. This is sum number 97, example 97, page number 3.58 in my Aurora. 12 cells, so the totally cells is 12 cells are there. Okay, number of cells. Okay, um, each of EMF 1.5 volts. Internal resistance is 0.5 ohms, are arranged in m rows and each containing n cells. So then there are n such cells like this, and there are m rows. You know, we have dealt with this derivation in class. And if this is n rows and this is m numbers, you know, it is n into E, and it will be n into R will be the EMF and the resistance across one particular row, and this will become 1 by nr plus 1 by nr plus 1 by nr dot 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 1 by nr, which will become m by nr. So it's equivalent EMF, equivalent resistance, smaller internal resistance is nr by m. This whole setup is being connected to an external resistance of 1.5 ohms. Okay, so then calculate the value of n and m for which the combination would send out maximum current through the external resistor. The condition for the maximum current is the external resistor has to be equal to equivalent internal resistance nr by m, which you already know. And you know that the total resistors is total number of batteries is 12, so which means how many numbers there are, can we say that m into n is equal to 12, therefore, because there are n rows and m column shows the total number of batteries, m into n is equal to 12. So you can write one in terms of the other. If you want, you can write n is equal to 12 by m and substitute it back here. A capital is R is equal to nr, which is 12 by m square, and an r here is equal to capital R. You know the capital R's value is 1.5 ohms, is equal to small r's value, you know, is 0.5 ohms internal resistance by m square. So therefore m square is equal to 12 5s are 60, so it will become 6 by 1.5 and it will become 4, and so then m is equal to plus or minus 2, but it can be only plus 2 because it's number of rows and columns cannot be negative. So that's one sum. Then is example 98, where you have a cell like this and a resistor like this, then you have a cell like this and a capacitor like this, and you have a cell like this and a resistor like this, and so this will be a 2R, this will be V, this will be V, and this will be V. This is a point which is B, and this is another point which is E. Then there is A, F, and C, D has been given. In a given circuit, in a steady state, the word called steady state, okay, as I explained in the class, means there's no current flows through the capacitor. No current through capacitor. That's what a steady state means. A steady state or a fully charged capacitor, in other words, fully charged capacitor will be in a steady state, because you know capacitor generally blocks a DC. Can you see the capacitor is connected to a DC? How does it block the DC? Until it charges. Until the charges are accumulated, it will continue to accept the current. Once that's fully charged, it blocks the DC, and that's when it's called a steady state. And a steady state, actually no current flows through the capacitor. So these are the key points. Therefore, you know that there's absolutely no current through this, which means if I'm going to draw the current, I'm going to consider this as I. I know what is coming out here is also I. Yeah, you might think of writing this as I1, and you might think, because it's positive terminal, you might think of writing it as I2. You don't have to do that. They are not two different currents, because the central wing does not have any current. So let's not call I1 I2, let's call it as an I which flows from here, which flows in here as I. What goes in comes out like this, because no current flows through the middle wire. So then the potential drop, okay, the question is first find the potential drop, then the charge and the energy through the capacitor, energy in the capacitor. Okay, so let's do the sum normally and then find out what can be the current that flows through. And you have R and 2R, okay, and so then let's do a loop rule. You can do a loop rule of the entire outer loop. Okay, we can take the outer loop alone. It's from negative to positive. So can we say it is plus V? We don't know the value of the voltage, so plus V. And the current is coming in the opposite direction, plus 2 IR. We don't know the resistor's value, we don't know the current's value. Okay, so let's proceed like this in anti-clockwise direction. And that they come across the current in the opposite direction, plus IR. And then again a battery which is from positive to negative, which is minus V, and come and close the circuit is equal to 0. And so V and V thus get cancelled. 2 IR, what 2 IR plus IR is 3 IR is equal to 0. Something is not okay, right? So let's we'll figure that out. Okay, so what is another way of doing the sum is you know that let's see, the potential between this end and this end will be the same as the potential between here and here. Yeah, the potential between, and in a steady state, when the capacitor is fully charged, no current is flowing through the middle one. So then there's no current which is going to flow through the capacitor. But that doesn't mean the capacitor doesn't have a voltage, okay? The capacitor would have got charged. The moment the capacitor would have got charged, it would acquire a voltage. Even though the current is not flowing, it will have a specific voltage, definitely. Yeah? Okay, so then let's talk about the net EMF, net resistance. What is it? It's 2R plus R is the equivalent resistance of the entire circuit, correct? Which is 3R is equivalent resistance. And the net voltage, if you are going to consider only the outer loop, it is negative and negative are connected, so it has to be V minus V, and one of it is 2V, I think. Oh, that is the mistake. This is 2V. Okay, sorry guys. Okay, so then therefore you can apply loop rule again. As I said, you can apply the outer loop, go from the beginning, start traveling from here, from negative to positive is plus 2, and then you have a resistor in which current is flowing in the opposite direction, plus 2I, and then go like this, go to the outer loop directly, a current is flowing in the opposite direction, plus IR, or plus 2IR here, okay? And the voltage is going from positive to negative, minus V. This is 2V, right? They've given it as 2V. So therefore it's this is equal to 0. 2V minus V is V, plus 2IR plus 3IR, 2IR 3IR is equal to 0. So thus you get the V is equal to minus 3IR. Therefore I is equal to minus 3R by V. That say V by minus 3R. So what am I saying? Minus V by 3R is the current that is flowing through the so first thing, you can disregard the middle wing itself, and you know that minus and minus are connected, and so it will become 2 and V will get 2V and V will get subtracted. 2R and R on series, so it will become a 3R. So you can calculate the equivalent current through the circuit. But it's in terms of R, and so let's continue. You got the current. So now that you got the current, you know the potential difference across B is the same as potential difference across AF, yeah. So potential difference across AF, you know the current is minus V by 3R. So potential difference across AF means you have to come from F to A in this direction. When you come, there is a current which is flowing in the opposite direction, plus IR, positive to negative, minus V, and this will be the potential difference. What is I? I itself is minus V by 3R into R, minus V, where R and R get cancelled. So it's minus 4V by R. It's minus 4V, no, R is not there, minus 4V by 3. Minus 4V by 3 is the potential difference from the right end to the left end, which is the potential difference across AF, which should be the same in the case of BE also, because they are parallel connections. And you know that there is a potential, there is a capacitor's potential which is an unknown potential X, and this is from, if you're going to come from the right to end to the left end, you don't know whether it's from, what is the potential, it's positive or negative, just write it's minus 4 by 3, 4v by 3 should be equal to, this is from negative to, this is when you come from right to left, it's from positive to negative. So there's a minus v plus an unknown resistor x. Okay, so let's see what x is. Minus 4v by 3 plus v. So therefore it's 3v. So it's minus v by 3. So you get the minus v by 3 to be the unknown potential, and so therefore you understand that's also from positive to negative, whatever, you don't have to, but the magnitude of the potential is v by 3. Thus you found the magnitude, the potential difference across is only the magnitude of the potential, which is v by 3. Thus you know that the potential difference across the capacitor is v by 3. So next is, you answered that part. Then next question is the charge in the capacitor. Once you know the potential in the capacitor, you know Q is equal to C into V. If you know the capacitance of the capacitor, it's not been given, then you can keep it as C into V by 3. This is the charge on the capacitor. That's the next part of the question. And the third part of the question is to find the energy of the capacitor, which is half C V square. You don't know what is C, keep it as C. But you know what is V? V is V by 3 from here the calculation. So it's V square by 27. It is 27, right? So half C V square, it's V by 3 the whole square, which is V square by 3 3s are 9, 9 3s 27. And so it will be C V square by 7 2s are 14, 2s are 54. The energy stored in the capacitor is half C V by 3 the whole square. Oh, it's only whole square, I'm sorry. V is just V by 3 the whole square, which is V square by 9, so 9 2s are 18. Thus you get C V square by 18. I'm sorry guys, a very difficult sum. I hope you understood how to do it. Okay, just trace it back and make sure you're thorough. I've taught this in the class also. Okay, I kind of messed up with the calculations in between, but I hope you're clear how to do the sum. So here comes the sums of, I'm going to do with heating effect of electric current. Some sums which will add value when you come across question papers is an example 99, page number 3.65. Okay, that sum, example 99, an electric current I is equal to 4 amps flows through a resistor of 12 ohms. What is the rate at which heat energy is produced in the resistor? Rate of heat energy produced in the resistor. Okay, you know rate of heat energy means power, because rate of energy by time or work by time is power. And you know power's formula is I square R. When you know I, it's 16 into R is 12. So thus you get very simple 192 watts is the answer. Simple sums for 1 mark questions. Okay. So then example 100. How many electrons flow through a filament of 120 volts? A filament is there and it's got 120 volts and it's got 60 watts, which means a volt is given, the rated voltage is given, and the rated power is also given. How many electrons will flow? Okay. So when the rated voltage and rated power are given, okay, you know P is equal to VI, you can calculate what is I, which is P by V, which can flow through that, and P is 120 by, P is 60, is it? Okay, P is 60 by volt is 120, so it's 1 by 2, which is 0.5 amps is the current that is capable of flowing in through it. Okay, the question is how many electrons can flow through. Once you know in how many seconds, per seconds, I is equal to Q by T. So Q is equal to I into T. The question is about per second. So then therefore, number of electrons flowing through, okay, will be, charge will be 0.5. Okay, what I get is a charge, 0.5 coulomb. But the question is about number of electrons. So 1 coulomb, if 1 electron has got 1.6 into 10 to the power minus 19 coulomb, 0.5 coulomb stands for how many electrons? You can just cross multiply. Okay, or you already know 1 coulomb of charge consists of 6.25 into 10 to the power 18 electrons. You must, if you have memorized this is good. Then 0.5 will be exactly half of it. So 3 ones are 2 ones are 2, 2 2s are 4, 1 2 5 into 10 to the power 18, just half of it. Okay, only the power cannot be halved, only the quantity can be halved. Okay, I hope you're clear. That's a beautiful question. Then example 101. The heating element is marked at 210 volts rated voltage. Rated power 630 watts. Marked means rated power, rated voltage. And when they what is the current drawn by the element when it's connected to? See, in this question they didn't say it's connected to anything. They just gave the rated power and rated voltage, and they're asking how many charges can flow, how many electrons can flow through it. So then, but here the sum is different. You have a bulb which has got a rated voltage and a rated power, 630 watts, and it's been connected to a 210 volt external DC supply, but rated voltage and the supplied voltage are just the same here. It's no difference. Okay, so then therefore you can the I that you can calculate using P is equal to VI will be the same as what is going to flow through the circuit. So then I is equal to P by V. So it's 630 by 210. Therefore it's 3 amps. You get the current. Now they are asking for resistance. Resistance of the filament is R is equal to I said V square by P. P is equal to V square by R. So we can just calculate V square, which is 210 into 210 by 630, 0 0 get cancelled. This is 21 3 and so 70. Therefore you can write 70 ohms. Aurora is doing something else, but for me when the rated power and rated voltage are given, I can directly find the inbuilt resistance of it. I have no issues in finding the resistance of the filament. I don't need the current or anything for it. So example 102. A 10 volt storage battery of negligible internal resistance is connected across a 50 ohm resistor made of alloy manganese. How much heat energy is produced in the resistor in 1 hour? Okay, and heat energy, power is rate at which work is done. So heat energy is this W, which is power into time. Power itself is VI into T. So then the heat energy is basically VIT. Okay, you can take VIT if you know the time. But in this question they have given resistance. So if they have given resistance, you can write I as V square, V by R, I as V square by R into T. So that solves your problem. So then V square is 10 into 10. They have given that volts is 10 volts. Where does it say 10 volts? A 10 volt storage battery is connected to a 50 ohm resistor. 50 ohm resistor into time in 1 hour. 1 hour is about 3600 seconds. Just do this calculation and you get 7200 joules. So that's about it. When they ask you heat energy is the work done, so you have to cross multiply and get an answer. So example 103. An electric motor operates on a 50 volt supply. Okay, the supply voltage, and draws a current of 12 amps. It operates on a 50 volt supply. The supply voltage is 50 volts and current draws a current of 12 amps. If the motor yields a mechanical power, of 150 watt, what is the percentage efficiency of the motor? Percentage efficiency of the motor. First of all, you should know that efficiency of the motor formula, efficiency's formula is output power by input power into 100. That's the efficiency. How much power it's taken? It's drawing some power, okay, but however it is able to output only so much power. So the ratio of how much is drawn to how much it's produced, how much labor it's done, or in other words output power can be how much work the motor has done. So output power by input power into 100. So then it yields mechanical power, means isn't this an output power? It is. We are able to get an yield of 150 watts, which will be output power. What will be input power? Input voltage is given, a current is also given. With that you can calculate the input power. Input power is just power is equal to VI is input power. It's 50 into 12, which is 600 watts. So then that will be the input power into 100. So cancel it off and you get answer 6. This is 75 by 3, and so it's 25% is the efficiency. So thus you understand how to do that sum. Let's go to next question. Um, let me skip some sums and go to better sums. So let's go to this sum. Brightness, current through it. Okay, there's a sum number 112. Let's try that sum. 2 electric bulbs rated 100 watts at 220 volts and 25 watts at 220 volts are connected in series. So you have this bulb and this bulb, both of them are connected in series, and I is a constant current that's going to flow through there. You can find the respective resistance. As I said, R is equal to V square by P. This is R1. R2 is equal to V square by P. P1 and P2. Power here is 100 watts. The power in this case is 25. Just substitute these values and you get the 484 ohms is this resistor, and this resistor is 1936 ohms. You get the two resistances, R1 and R2. They both are in series, so then it has to be added, and R equivalent is addition of 484 plus 1936, which will give you a 2420 ohms. Now you know the current is going to be the same, and let me read the question. Calculate the current through them and the potential difference across and actual power consumed. Actual power consumed is nothing but equal to brightness. Okay, so you know that the brightness is based on power consumed, for which I is a constant. So I'll use for power consumed, I'll use I square R and I square R1 and I square R2. That will give me my power consumed or brightness, correct? So with that I can do this, for which what else have they asked? They asked potential difference, current through. Did I find the current? I found the equivalent resistance. I know that they're connected in series across the 220 volt. So the external voltage is also 220, which is same as the rated voltage, so no problem. So therefore you can find the equivalent voltage is 220 and the equivalent resistance is 2420. 220 by 2420 will give me the current flowing through the circuit, which is 1 by 11 amps. So it's 1 by 11 amps is the current that's going to flow through the entire both the bulbs. Once you know that's the current, you can find 1 by 11 the whole square into R1, which is 484, and 1 by 11 the whole square into R2, which is 1936, will give you the power consumed, which in this case will be 4 watts and this is in this case 16 watts. So this bulb will glow with the maximum brightness. Obviously you know the low power in series will glow brighter, and that explains it. Superb. So then next is voltage. They ask you the respective voltages. You know the current, you can multiply it with resistance. You know the 1 by 11 into 484 will give me the voltage across this, which is 11 4s are 44 volts, and 220 minus 44, the balance of it will come here. So it is 176 volts across this. Okay, so that's the sum. Very beautiful sum. Okay, let's go to next question. Calculate distributed. Okay, I think that is enough. Okay, so similarly, if it is in parallel, you know you would calculate the respective resistances and write equivalent resistance. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and then reciprocality, you get the equivalent resistance. In that, voltage is a constant. For consumed power, you have to use V square by R, V square by R, V square by R. That's the only difference. Other than that, there's no other difference. Okay, so I'm sure you all understood how to apply this. If they ask you questions on bulbs and stuff, there's so many other sums that are there which you can slowly eventually do later once you're clear with the basics, because what's going to come is only what I've taught you. You can take it from me. Okay, so I'm stopping with this this video.